So what is, well, I already said that lets you do heavy computation in a centralized location. Now, cloud might be a little misleading on this slide here. It could be the server farm that Stefan mentioned, which is located in your basement. It could even be your local machine. What's important here is that GAMS Engine allows you to do the computation on a centralized place. And the way to interact with GAMS Engine is the gateway here. So this is a REST API that you interact with, and whatever is inside this cloud here doesn't need to concern you. That's the basic idea of Engine. So you really have to just tell GAMS Engine to, okay, this is a job that I want to run. How you run that job is your problem. Now, this cloud here could contain multiple GAMS workers, and they could be on a single server. As I mentioned, they could even be on your local machine, but typically they are in a whole farm of servers. That's what I already mentioned. Maybe a little bit about the architecture of this system. So this is a typical Dockerized application with multiple microservices. The most important one being the what we call broker gateway was already mentioned before. It's a REST API. That's important. It's a REST API, and that API takes all your commands and then schedules those jobs in a queue. And then whenever there is free computational resources available, those jobs are taken by one of the workers, solved, and given back to the broker so that you can retrieve your results. And so there are multiple clients that can interact with GAMS Engine. The most obvious one that we've talked about the past minutes is Miro. It could be Miro Desktop. It could be Miro Server. Also, GAMS Studio supports running jobs on GAMS Engine. GAMS Engine comes with its own kind of web interface that is meant for administrational purposes mainly. And then GAMS Engine comes with APIs to all sorts of programming languages. And that's because we follow what is, for those of you who have worked with REST APIs before, it's called Open API specification. And if you follow that, you get clients for all sorts of programming languages for free, basically. So this is a specification for REST APIs that we follow. Now, all you need to be concerned with when interacting with Engine is the REST API. How your jobs are scheduled is the problem of Engine. You don't need to be concerned with that anymore. And so this could be a single server, or this could be multiple servers, a whole cluster of servers, or even a cloud environment where you dynamically scale up and down your computational resources based on the demand you have. And let me go back to give you a quick demo here. Now I can launch my example app that I've previously deployed. You can see that this looks very familiar. This is exactly the interface we had before. I can solve my model here again. It solves, gives the results, and displays my charts. So this is my deployed application. Now I would like to do the computation here, not on my local machine as it's doing here. I would like to move that to an instance of GAMS Engine. How do I do that? But first, I close this app again. I go to the Settings tab. So I go to Preferences here. And I say that I want my models to be executed on GAMS Engine. So I turn this switch on, click on Apply here, and launch my app again. Now you can already see that something changed. I have a form now where it asks me to enter a URL, username, password, and a namespace. Namespace, you can imagine it as a folder where your model is executed. So let me enter some credentials here. So this is the engine instance that runs on our server at the moment. The username is informs, password, and the namespace is also informs. So now I click on OK, and now I'm logged in. So the interface looks identical to before. I have, again, my two sliders here. I have my table with the price data. I have my README, and now I can click on solve here. And you can see that this is now being submitted. The model is queued. The results are being downloaded, and I get the impression that nothing changed to the previous run. It looks exactly identical. The only difference being that now this model here was solved on a remote server. And that's the whole idea. Move away the computation from your local machine to a centralized server. And you do that with the use of GAMS engine. Let me close this now and switch to my browser, where I already opened the engine interface, so the web interface that I mentioned previously. Now, what you see here is that this is the overview of my jobs. I have a job here, which was submitted just a minute ago. That's the one I just solved. And then if I click on show here, it's showing me the information of this job. So I have my Miro log file here. I have my log file here that you've already seen in Miro as well. I could download the results, and I have all the information of this job. So that shows me that this was run indeed on an engine instance. Is my internet laggy, or it seems like I'm very slow?
Yeah, maybe you should.
So this interface.
Turn off your video.
Yeah. I hope it doesn't break up here. So this interface is basically meant for administrative purposes. So you have your overview here. You can see models that are registered in your namespace. You have the users, and in this case, it's just me. But you could have multiple users that even have a hierarchical structure, as well as different permissions. So maybe some of your users should be allowed to just see the data of the models that were run, while other users can submit new jobs. So the whole user management is behind that thing. And to emphasize this aspect of a model here, I want to switch again to an example which I've prepared for this purpose. So when you submit a job to engine, what Miro did in the background when I clicked on solve was it collected both the model data and the input data of your scenario and sent both of that to engine. Now, obviously, if your model doesn't change for different scenarios, which in the case of Miro, it doesn't, you would like to avoid having this additional traffic of always sending along your model. So what you can do is you can register your model files, the part of your model that is static, and only send along the dynamic file. So let me demonstrate how that's done here. I can go to add model, and I just go to this invest dispatch model here that I will explain in a second, and I have the zip file. If I look into that, it consists of just 3 GMS files that depend on each other. I zip this here and I just put that in here, and I say add model, and there you have registered a new model. Now you go to jobs here and you say new job, and you select the namespace. You say I want to use a registered model, and you say I want to use this simple informs model. Now what this gives you as an advantage is that you don't have to send along these files of your model data any longer. You only send along the dynamic stuff, the between. So in this case, my here, which consists of 2 CSV files. So I would just drop that in here, and I guess I need to add some command line arguments for this example here. So let me copy that, go to advanced options and add some command line options. This is the equivalent of this command line up here in Studio. GAMS comes with all sorts of options and ways to customize the run. For example, change the maximum time of that the solver is allowed to run before it should give you a solution. That obviously might not be the optimal solution that it found in the restricted amount of time you specified, but you would like to have a solution after some time, and that is configurable via command line options. It's just an example here. And so here I have a couple of options that I specify here. I just submit that job, and you can see that it's now running. I can query the log here. You can see that it's completed, and it's showing me the log file here. So this is just a way of submitting a job, right? This is just now solved on a server instead of your local machine. And apart from that, it all works as if it would be solved on your local machine. You could download the results here again. It's really, really slow right now. And you can look at the results, and you can see that it gave you quite a lot of results here. In this case, this GDX file contains all the data of my results. So for example, I can take a look at the objective function variable which has a value of 10,000, and that's my result of my model run here. Now, maybe to show one more use case for Engine, which this model is actually designed for, is this model consists of 2 parts. It's a typical energy system model where you have an investment model that does some investment decisions, and based on those decisions, you have multiple dispatch models. So you run your invest model that gives you a solution, and with that solution, you spawn a couple of dispatch models that give you the dispatch of the different generators, right? So this is a typical business logic that you would like to implement. And I will use this as an example to show you how you can interact with Engine in a programmatic way. I mentioned that there are multiple APIs, and this is a way to demonstrate how to leverage the power of these APIs. So first, I'm using Python here as an example because I believe this is a very nice way to, without having too much boilerplate, to understand what's going on here. First of all, I'm specifying some settings. So I say I want to use a model which is called simple informs. I need to specify the file name where my log output is written to. I have the command line arguments that I've shown you from before that I specify here. This one here is the number of slices. So how many reactors do I want to solve? How many dispatch models do I want to submit? I have my password here. I have my data and some other stuff which we are not using here. here I set up the configuration of my engine instance. So the URL, the username, and the password. I specify the namespace, which is informs. And now I'm posting that model. So all I need to do is I use this jobs API of engine. So GAMS engine job API gives me a job API instance, and I create that job. So this is just a method of this jobs API, create job. I hand over the configuration that I've set up previously. So the model, the namespace, the standard out file name, and here I hand over the data. So again, if we go back, these two CSV files, right? Everything I just did via the web interface, I'm now doing in a programmatic way. So I have this data.zip here that I specify here. I have my command line arguments, and I append these with the mode invest. So this instructs my GAMS model to run in the invest mode, and I tell it to use 4 threads. Now this method gives me back a token, a unique identifier for my job. If I go back to the web interface here and I go to jobs, you can see that here is a token. This is how a token looks like. It's just a unique identifier of my job that I can later use to query that job. Now let me go back to the Python example here. So I'll just echo that token here. And then while the job is running, I use this pop job logs method of, again, my jobs API instance. That gives me the log of my job. So I want to print that, which I do here. And this call gives me another Boolean as a return, which says queue finished. That means that the logs are finished. That means that the job is finished. So I know that, okay, now I set my finish to true, and I do this until finished is, is true. So then I jump out of that loop here and I retrieve my results. I check if the GAMS status code was actually not equal to 0, because in that case, something went wrong with the GAMS process, right? So maybe you had an execution error, maybe your model was infeasible, or all sorts of things that can go wrong. If that is the case, what I do here is I report that. And I get my results. So this method here, get job zip, returns me my results. And from that, I extract this invest_p.gdx. That's exactly the file I've seen when I did this kind of interactively via the web interface, right? I got my invest file, and that has all the results from my invest run. Now, I would like to use that file because I need it for my previous for my dispatch runs, right? So I extract that file from it, and I append that file to my data.zip. That's what I do here. And now I generate a number of jobs that we call a Hypercube job. So a Hypercube job is basically a set of jobs that only differ by the command line arguments, right? So let's say all these jobs use the same GDX data, the same invest, but they run for different generators. So I control that via GAMS command line arguments. So here I have this _time slice, and that tells me solve this time slice, this particular time slice for my dispatch run. And so what that would look like if you go back to Studio is you would say, I will run mode equals dispatch and I want to run time slice equals 1. And then you run time slice 2, time slice 3, time slice 4, time slice 5, right? The data doesn't change. The only thing that changes is your set of command line arguments. And in order to not, in order to reduce the traffic of sending along this potentially large data file all the time, Engine comes with something we call a Hypercube job that does allow you to only send your data along once, and then Engine does the work of expanding that into multiple jobs with different command line arguments. So what I do here is I create this Hypercube description file. I give this, every Hypercube job has an ID, so I can later identify it. In this case, I just name it dispatch_I, and I have my different time slices as the only part that differs for the command line arguments. I will skip over that one here. I create my Hypercube job. I again see how many of my jobs are finished, and if they are finished, I collect my results. Without going into the nitty-gritty details here, I guess the idea is pretty straightforward. So I have my invest model, I get the results from my invest, I launch a couple of dispatch models, and I'm interested in the dispatch results of all these models. And so in order to demonstrate that to you, let me quickly run this here. So if my internet speed is actually capable of doing that, now it solves the invest model. You can see that is echoed to the console here. So it's solving the invest model. It downloads the results of the invest model, and hopefully soon you will be able to see that it generates the dispatch runs. So it says posting 10 dispatch models. It uploads the data again to Engine, and Engine takes care of solving all these dispatch models and give me back the results. Right. And I don't know if I want to wait here. My internet seems pretty flaky at the moment, so the upload and download speed might be kind of low right now. Right now it posted this Hypercube job and it queries the jobs. So 4 out of 10 are finished right now, 8 out of 10. And once all of them are finished, it downloads the results again. And now it's done. If I go back to the folder here, I can see that some dispatch results, which was just generated here, some directory is here. So if I look at, for example, dispatch PP1, sorry, and for example, look at the power generation here, I can see the levels. So the power generation of my generator for T1 until T24 or something. And if I go to, for example, the time slice 8, you can see that now I have T3067 and so forth. So I have kind of disaggregated my runs and parallelized them to solve them quicker. Okay, and with that, I conclude and I hand over to Atarv to collect questions, I guess.